Hi, my name is Poorvi Datta and I'm a student at UC Davis majoring in bio. Today, I'm going to be talking to you about our brain's sense of time. Humans evolved in an environment that's constantly changing.
Watch out!
Responding to, these types of changes involves being able to estimate time accurately. And to do that well, our brain needs to use multiple forms of input, like visual signals, auditory signals,
Watch out!
and motor input. However, interestingly enough, not much is known about how our motor systems and our sensory systems work together when we estimate time, despite the fact that they work together for lots of other tasks, like speech. Our project at the Sensory Motor Integration Laboratory at UC Davis takes a look at this. We hypothesize that motor activity is a more precise form of input than auditory input, implying that, with a combination of the two, people would estimate time more precisely than with either alone. This is called optimal cue combination, where our brain examines different forms of input, weights them based on their reliability, and integrates them into one more precise time estimate. To test this, we set up a task where participants had to first internalize a time interval, and then try and reproduce how long that interval was by pressing a button. We had 3 trial types, which differed in how participants sensed that interval. The first was auditory, where they held the mechanical arm but could not move and heard a tone. The second was movement, where they moved the arm freely until a brake was applied, no tone. The third was movement auditory, where they moved the arm freely and heard a tone at the same time. So what were our results? Well, on a group level, we didn't see the precision effects we'd predicted under optimal cue combination. However, on an individual level, we did find for most participants that movement was more precise than auditory. We also found that accuracy was highest in the combined movement auditory condition. Overall, these results are super important for understanding more about our brain's sense of time. So next time you catch a ball, tap along to a catchy song, or talk to a friend, take a sec to think about, how are my motor system and my senses working together to help me respond to my environment?